This circuit is a combination circuit like belief number 5 on your package. So you see that there's two resistors, R2 and R3, that are in parallel to each other, but then they are in series to R1, which is then of course connected to the battery. Some concepts: in a series circuit, the voltage is shared and current is the same. In a parallel circuit, the voltage is the same and the current is shared. Okay. And to find total resistance, here are the two formulas. This one is for series circuit resistances, this one is. And for parallel circuit resistance is this formula. Okay, so what we have given is the resistors 1 has 4 ohm, 2 has 10 ohms, and 3 has 12 ohms, and we have a total voltage of 40 volts. So this one is at the battery, okay? So 40 volts is at the battery. Again, we're starting similar like the other two circuits with finding the total resistance. Now the problem here is that we have a combination of parallel and series. So we're going to start with the two parallel circuits, with the two parallel resistors, and we're finding the total resistance of those two, that's R2 and R3, so the 10 and the 12 one. And using this formula, so 1 over total resistance is 1 over R1. Well, actually in this case it will be 1 over R2 plus 1 over R3. And we get a total resistance here of 5.45. So those two is 5.45. And then those two are in series with a 4 ohm resistor. So we simply add the 4 to that. Gives us a total resistance of 9.45. Okay, so one more time, find the total resistance from these using the formula that you use for parallel circuits. And then, because these are in series with R1, you add R1. In this case, gives us 9.45. Now we have, on the total part, we have the total voltage and the total resistance. That means we can now find the current. So the formula for the current, this one here, I equals V over R. And if you do that, you get 4.23 right here. 4.23, okay? Now the 4.23 current, you find everywhere between this point and this point, because at this moment you have the same current everywhere, the same number of electrons floating around here. When it gets to this branch point, that's when they split up. But between here and here, we have the 4.23 ampere. That means through resistor 1, we have 4.23 ampere. So we can put that right here. 4.23. The other ones we have to find out later because it splits up. So we have two variables now for position 1. We have current and resistance. Then we can find the voltage. And this is the formula. Voltage is I times R. So the 4.23 times 4 gives us 16.93. 16.93. Now we know that the voltage is the same in parallel circuits but shared in series circuits. So we have part series, part parallel. We know that out of the overall voltage, 16.93 is used by resistor 1, and the rest, the difference between that and the 40, is used by this package here. Okay, so first we find out what is the difference between 40 and 16.93. So just make one minus the other, you get 23.07. That means in the parallel part you have 23.07. 23.07 for this and 23.07 for that. This is not divided by 2, okay? It's the same. So we can write 23.07 here and 23.07 there. Now we have again two variables, and we can now find the current with this formula again. I equals V over R. So 23.07 divided by 10 is then 2.31 rounded, okay? 2.31. And 23.07 divided by 12 is 1.92. Okay, now we almost got everything, just left is the power. power, you use this formula, P equals I times V. So for the power on each position, we multiply those two values, and I get 71.61. Oh, sorry. 71.61. For position 2, 53.29. Position 3, 44.29. And then the overall is 169.2. There's two ways to get there. You can either add those all up, you get the total, or you make 40 times 4.23, also get the total.